All right, welcome back, class. So this will be 8.1D, and this is more properties of rational exponents. So before I begin, I want to preface this lesson by going over adding like terms. This will be familiar, and it's as simple as starting with 5 plus 3. So in this case, they are both integers, so they're like terms, so we can add them together. So 5 plus 3 is 8. I think that looks pretty familiar to us. Following, now we have some more like terms. So if we have 3x plus 4x, we're like terms because we have x's. It's just now our leading coefficients are different. So we're adding 3x plus 4x. So how many x's do we have? We have 7. 7x. Okay, so now what if, in that case for x, what if we set x equal to the square root of y? Okay, so now we can plug in square root of y for x. So then we have 3 square roots of y plus 4 square roots of y. Now it looks different, but we set x equal to the square root of y. So now when we add, it's the same thing. We have x, they are equal. So now when we add, it's the same thing. That coefficient is going to add together. So 7 square roots of y. So it looks like it may be confusing or hard to understand, but it's the same concept because we need like terms. So in these cases, we need to make sure that our index is the same. We need to make sure that our radicals must be the same. The exponents, so if it's to the x power, those must be the same. And then again, the bases for like a would be the same. Oh, by the way, I should use a different variable. I think on the outside I'm going to put, n. So then when we simplify that, the index, remember, is in the denominator. So it'd be like x over n. So x goes to numerator, n goes to the denominator. So if we add like terms, they must be familiar here. So let's try and start here. I'm going to start with this one, because in this case, we have our base is the same, and then our index is the same, and they both have those implied coefficients, exponents of 1. So these two are the exact same thing. So just like when we had 3x plus 4x, now it's 2 sixth root of 3 plus 7 sixth root of 3. So when we add them, we get 7 sixth root of 3. This highlighted part stays the same. Oops, excuse me, 9, because we needed to add 2 plus 7. So 9, because the coefficients are now what we're adding when we have the same term here. The exact same term. So now when we go over to this one, our terms are a little different. It's 6 cubed roots of 5 plus 4 cubed roots of 625. So they're similar, but our bases aren't the same. So first we're going to want to see if we can reduce or simplify this second one, and I think we can. So 625 is 25 times 25, and I went one step ahead. And we can simplify that to 5 times 5 times 5 times 5. So because it's cubic, we want 3 factors. So we have 3 factors there, so we can pull out a factor of 5. However, let's not forget, we already have a leading coefficient of 4, so when we pull that 5 out, I'm going to do just that second part off to the side. It's going to be 4 times 5, because we pulled out that factor of 5, cubed roots of, well, what's left on the inside, we have 1 factor of 5. So now we have 6, I'm bringing it down, cubed roots of 5 plus 4 times 5 is 20 cubed roots of 5. Alright, now let's see if our terms are the same. We have cubed roots of 5, cubed roots of 5. Our exponents are the same, so these are the exact same. Now we can add like terms. So we have 26 cubed roots of 5. And that's it. We just need to be looking to see if our terms are the same. Okay, so that was adding up there. Now we have subtracting. So 8 square roots of x minus 3 square roots of x. Square root of x, square root of x. The index for both are 2 because it's squared root, and the exponents, there's that implied 1 for the exponent. So they're the exact same. So we could do 8 square roots of x minus 3 square roots of x. So we would get 5 square roots of x. And then that would be simplified down. Alright, now let's look at this one. Both have gh to the 4th power. It's 3 times gh to the 4th minus 6 times gh to the 4th. So let's look at those terms. Let's disregard these coefficients. So the coefficient 3 and 6, don't look at them for now. Just pull out gh to the 4th. Is that the exact same thing as gh to the 4th? Yes. These terms are exactly the same. So now we can subtract, I don't want that 6 in there. We can subtract the coefficients. So when we do 3 minus 6, or 3 times gh to the 4th minus 6 times gh to the 4th, we will get negative 3 gh to the 4th. Because when we do 3 minus 6, you can think of it as 3 minus 6 or 3 plus the opposite of 6. So you get negative 3 gh to the 4th. That will be simplified down. It might look a little messier, challenging right now, but what we're looking for is our terms here the exact same. Then we can do those addition and subtraction properties. Alright, once again here, I'm not going to multiply or simplify this 4 to the 3/4 power. I'm just going to leave it as it is. That's why we have the quantity around it. So what we're looking for again is, are these terms here the exact same? Don't look at the coefficients of 5 and 3. Is 4 to the 3/4 power the exact same as 4 to the 3/4 power? Yes, it is. This is the exact same as that. So now we can subtract those leading coefficients. So 5 minus 3 would be 2, and we still have 4 3 to the 3/4 power. That would be our final answer here. Next, so our index needs to be the same, our bases need to be the same, and our exponents need to be the same. But in this case, our bases are not the same. We have 81 and 3. So let's factor this to see if we can pull out any factors. So we have 9 times 9, and then we have 3 times 3 times 3 times 3. Because it's cubic, we need 3 factors of 3. So I see 1, 2, 3. So now when we rewrite this, we have a factor of 3 we could pull out, and then what's left is the cubed root of 3. There's one more factor of 3 in here. Minus, in this case, it's cubed roots of 3, and if there's no coefficient, then there's an implied coefficient of 1 times that. So you can rewrite this as 1 cubed roots of 3. Now you can see that it's basically 3 cubed roots of 3 minus 1 cubed roots of 3. These terms are the same because we have I guess I could have included the 1, but because we have the same index, the same base, and the same exponent. So now we can subtract them. So when we subtract, it'd be like 3 of this minus 1 of this equals 2 of cubed roots of 3. Hopefully you're starting to feel a little more comfortable with it. Okay, now in this case, our bases are the same, 6x, 6x. Our indexes, or the radicals, 4th root, 4th root. But we have not simplified this one yet. So our exponents are not the same. So how many x's are there under the radical? It's x to the 5th, so there'd be 5. 1, 2, 3, 4, 5. It's to the 4th, or excuse me, the 4th root, so we want 4 factors of x. So 1, 2, 3, 4, so we can pull out an x, so then it becomes 2x. And then what's left on the inside? Well, it's the 4th root. We are going to leave our 6, and then we still have a factor of x. So 6x plus x. This one is simplified, so 4th root of 6x. Now, our leading coefficients are going to be 2x, and then again there's that implied 1 in front of there for the leading coefficient, so 1x. So is x times the 4th root of 6x the exact same thing as x times the 4th root of 6x? And we can include that 1. It is the same. So now we can add them. 2 of this plus 1 of that. And if you're guessing 3 of that, you're right. 3x 4th root of 6x. And then that'll be it there. Okay, over here, now we have review. So, and this will tie into this lesson. If we have the same base and it's the product of the two, we're going to add the exponents. So x squared plus the square root of 3. And what are we trying to relate this back to? Well, what we're doing is that we're showing now the exponent is not like terms because we have an integer and an irrational number. So since these terms are not like, we cannot add them together like we can over here. So we're kind of relating back to the first lesson where we add the exponents for the product with the same base, and now showing that we cannot add different terms. They need to be like terms. So this would be simplest form here. And finally, we have the composition of roots. So remember, the square root of something like x can be rewritten as x to the half. That's because the square root, the index is 2, so then that 2 goes in the denominator, and then the exponent is 1, so that 1 goes in the numerator. So when we do this composition of roots, let's do the outside first. So the square root becomes that thing to the half power. So what's left on the inside? Cubed roots of x, and then the square root becomes to the half power. Now we can do it to the cubed root. We have that implied exponent of 1, and then the index is 3. So now when we do the inside, what's left is the base. We're going to do the exact same thing where now that exponent goes in the numerator, and then in the denominator goes the index. So it's x to the 3rd power, and that's raised to the half power. Now we have a power to a power. So when we have a power to a power, we multiply them. So we get x to the 6th, and we can write that as this 6th root of x. So either of these two answers will be accepted. They are equivalent. Now let's do it with this one. First we're going to do the outside. So what's left is the square root of 5. The index is 3. So then it becomes the third power. Now we can do it to the inside. So we still have our base of 5. The square root is the same as the half power raised to the third power. So again, we have power to a power. So when we multiply those, we multiply across, so it's 1/6, just like the last one. And you can rewrite that as 5 to the 6th root. Okay, now in this case, the inside is the square root of y. So when we rewrite the outside, it's to the 5th root, so our index is 5. And there's that exponent of 1, so it's 1/5. And then we can rewrite the inside. So our base is there. It's the square root, so that's rewritten as the half to the 5th power. So again, we have power to a power. It's that composition of power. So we multiply those. So we get y to the 1/10, because I multiplied half by a 5th. So our denominator is our index, so you can rewrite that as the 10th root of y, and that numerator would be to the first power if you want to see that there. So these two would be equivalent, both would be accepted. Alright, thanks for watching.